All right, this is the second day on inverses. You need to have out worksheet 20, 21, and your colored inverse unit circle that we started yesterday. Everybody ready? I would like to start by adding something to our inverse unit circle. You don't need a marker, just a pen will do. Okay. What I want you to add, guys, is the actual range of values, okay? You can only answer between negative pi over 2 and positive pi over 2 for arcsine. For arctangent, it is the same, except you can't include those two values on the ends because those are asymptotes. The tangent is undefined, so there's no such thing as the inverse tangent of undefined. And the cosine, remember what we said for here? 0 to pi, okay? Quadrants 1 and 2, 0 to pi. Now, I know that's kind of down in the corner here, so let me do this. Just kidding. There we go. Did I stop recording? Oh, I don't know, it disappeared. Okay. Can you see it now? All right. Now, real quick review of what we did yesterday for those who were gone. Okay. When these inverse functions are equivalent to, by the way, sine -1 means the same as arcsine, okay? Cosine to the -1. By the way, we had a big discussion about this earlier today. Remember when we did functions? Now I'm getting off track a little bit here, but this clarified something for somebody yesterday or today. Remember when we did functions and we said to find the inverse of this, and then we were all done and we changed it back to this notation? And remember, it didn't look like this, right? It wasn't a case of just to the -1 meant flip it over. It actually meant switch the x and y, subtract and divide. So the answer here was x minus 3 divided by 2. You remember this now? Okay. Because this notation, if we saw x to the -1, we'd think 1 over x. But when it's on the function like this, it doesn't mean that. In the same way, this does not mean this. Okay, this has its own definition. It's cosecant. But this means figure out where a value occurs. It's the inverse sign. It means find an angle. Okay? Am I helping at all? Because somebody had this confusion today. Why doesn't sine to the -1 mean cosecant? Okay. All right. Back here. What we were doing yesterday, for those of you who were gone real fast, if it said find the inverse cosine of 1/2, right there like that, that would mean find where the cosine is x, so it would be find where the x value is 1/2 in the blue areas. So the x value is 1/2 right up here at pi over 3. If it said find the arcsine of -√3/2, okay, this question, if this had been on here, that means find where the y value, because it's sine, right? Where the y value is -√3/2, but arcsine is shaded red, so in these two regions. Now, it's here is the y value, and we renumbered this because of the restricted domain here. It said we have to answer between -pi/2 and pi/2. So instead of calling this 5 pi over 3, we have to answer that this occurs at -pi/3. All right, so that's a super fast review from yesterday. Then there was tangent. Tangent is not on our unit circle. It's not the x coordinate or the y coordinate. It's the y over the x, right? So we talked really briefly yesterday, or quickly, not briefly, but we tried to go quickly through it. The tangent here would be square root of 3 over 1 or square root of 3. You can't write that on your unit circle, though. You have to know how to find that. The tangent here would be square root of 2 over square root of 2 over 1. The tangent here would be 1 over square root of 3, which would rationalize to be square root of 3 over 3. Everybody okay? Tangent? Same values happen down here, but they're negative. So tangent is tricky. All right, back to what we're doing today. Oh, just kidding. Where am I going? Here we go. There's a chart, I think, on your notes, maybe, that says if you have an inverse sign and then you take the sign, it's going to cancel and become x. And that's true anytime the x value is between -1 and 1. It's also true for cosine between -1 and 1, and it's true for tangent if the value you're asked to find is anything, basically. If you're asked to find the sine of something and then the inverse sign, it only works if the value you were asked to find is between -pi/2 and pi/2, then they cancel each other out. Cosine and inverse cosine cancel each other out as long as that value you were asked about was between 0 and pi. I don't have this memorized. I don't want to think about this. I don't do it this way, okay? When I see this question, I would be very tempted to cross those out and just say 5 pi/3. But if you look up here, it's actually one of these. And is this less than pi? 5 pi/3 is more than, so it doesn't cross out. I would never remember when they do and they don't. So just like when I had this problem way back when, I always said I'm going to put the x value into the g and then take that value and put it into the f. I just did the problem backwards and I got the right answer. Okay, the same is going to be true here. If you go to 5 pi/3 on your unit circle, now be careful, 5 pi/3 isn't on your unit circle anymore, right? We crossed it out. But it's 330 degrees. Can you find where that is? This is asking what is the cosine at that spot? And the answer is square root of 3. No, is it 1/2? Cosine at 5 pi/3, 300, so it's 1/2, isn't it? Okay. What? I said 30? Oh, 330? No, it's 300. Yes. Thank you. Okay. Back up. 5 pi/3, okay, is the same as in the -pi/3. So it's at the 330. 300. Oh my goodness, I'm going to say it again. So the cosine value at that spot is 1/2. Now, once we've taken care of that, we go here and we say, where is the cosine 1/2? And then you go back to quadrant 1, because now it's a positive cosine, inverse cosine, and it's 1/2 up at pi/3. Yes? No? Okay. A lot of times they are going to cancel each other out, but not always. So I always just do the problem. So what in the world am I talking about? Well, let's try this question. I'm going to skip 11 for a minute. Look at number 12. Start from the inside. It says, what is the regular old cosine value of pi/2? So I go to pi/2 and I give me the x coordinate, which is then it wants to know my arc cosine, which is colored blue, where, I had to get rid of these exercises, Where is what angle has an arc cosine of 0? Right up here, pi over 2. So that particular question, the cosine and the arc cosine did just cancel each other out, and we got back to pi over 2. Right, I'm going to make up a couple more examples because there aren't good examples on here. If it said find the sine of the inverse sine of square root of 3 over 2, okay? This is saying, where is the square root of 3 over 2 happening at? So that's a y value, right? So it's at pi over 3. Now, what is the sign at pi over 3? Square root of 3 over 2. That's a really bad radical sign. Okay, so they did cancel each other out. Let me give you another example where they don't cancel each other out, okay? Do sine again. Can anybody tell me right away why you might know that that's not going to cancel each other out? 2 pi over 3 is not in an arc sine. Okay, but go to 2 pi over 3. Tell me what the sine value is. Y value, right? Now, arc sine or inverse sine is positive in quadrant 1. So now I need a quadrant 1 angle that has a sine of square root of 3 over 2 or a y coordinate. Okay, so sometimes they cancel each other out, sometimes they don't. It depends sometimes whether the sine or inverse sine is on the outside. So I just do them inside out and I'm done. All right, let's talk about 13 real fast. 13, go to 3 pi over 2, which is probably not labeled on your colored unit circle, but 3 pi over 2 is 270. Everybody find it? Tangent is y over x. What do we get? We get 1 over 0, which is undefined. There's no such thing as the inverse tangent of undefined, okay? Yes, if it exists. So you have to say does not exist or not possible. And part of the reason for that is because there would be two places. Okay, it would be at negative pi over 2 or positive pi over 2. But that's why they're rounded brackets. They're not actually included. All right, now I'm going back to 11. Number 11, is that negative 3/4 anywhere on my unit circle? No. It probably does cancel, yes. But let's talk about what we're going to do to find this, because we're going to have to do some where they don't cancel. Negative 3/4 arc sine is one you would have to draw. We can do this because we know Pythagorean theorem, but we don't need it for this question, I don't think anyway, because I think Kate's right, they're going to cancel. But what quadrant is arc sine negative in? It's either 1 or 4, and it's negative in 4. This is opposite over hypotenuse. So if I wrote a 3 here and a 4 here, right? Which one would have to be negative? The 3, because it went down, yes? Okay. Now, it's asking what's the sine at that spot. Do we even care what the angle actually was? The sine was just negative 3/4. But we're going to have to do some like that, where we have to use Pythagorean theorem, because look what they're going to ask us over here at 14. These aren't obviously going to cancel each other out, right? Because they're not even the same function. All right, so when we get to 14, we go to where? Go to pi over 6. We pick out the cosine, which is the x value, yes? Which is square root of 3 over 2. Now we're done with the insides. Now we have to find a sine value of square root of 3 over 2 in our shaded red area, which is quadrant 1 because it's positive. How are we doing? We didn't worry about it. No, we just drew the picture because in the end, after we didn't find this angle because we just wanted the sine of it anyway. Yep, good question. We just used it to draw the picture. When it's not on the unit circle, you can just draw the picture. All right. Couple more together. What do you think? Are you ready to try a couple on your own? Same as sine -1. Okay. Good questions. All right. Try these 4. See how far you get. Talk to somebody next to you. It really does help if you talk through this in words. So there's the words for 15. A lot of words. Yep. I think so. Hang on. All right. So for 15, I wrote out the words. Find the angle whose sine is 1/2. What did you get for that? The angle whose sine is 1/2. Pi over 6. Okay. By the way, it wouldn't matter if you answered that in degrees, right? For this particular question. But we do inverse sines in radians. I will tell you on worksheet 22, they do some in degrees. It specifically asks you to find it in degrees. Okay. The second part of the question says, then find the cosine at that spot. So now I need to find the cosine at pi over 6, which is just the x coordinate, which is square root of 3 over 2. Number 16, I wrote out the words. Find the angle whose sine is -1/2. Because it's an arc sine, it would be in quadrant 4. I'm looking for a y coordinate of -1/2, which in quadrant 4 happens at -pi over 6. And then it wants, though, the tangent at -pi over 6. Well, back up a minute. Its coordinate was square root of 3 over 2 and -1/2. So tangent is y over x. Remember the denominators when we flip them over and multiply by the reciprocal, cancel out. So we get this, which we need to rationalize to negative square root of 3 over 3, which is the answer to number 16. Yes? How many of you had that one right? Nice. Okay. What about 17? Okay, a whole bunch of you figured that out because I always picture that when I get a value over 1, I have to think about what's going on. And cosine, picture the graph. Does it ever go above 1 or below -1? If it was an arctangent, yes, right? But an arc cosine, no, cosine never goes above 1 or below -1, so it can't be 2. So we can't undo this. It's just not possible. Or does not exist, not possible, whatever you want to write. Yep, no works for me. Nice try, Hoffbauer. Yes, that one works too. All right, guys. 18. This is the hardest kind for students because it's asking you to find a tangent and it's not on your picture. Yes, but I'm going to talk through this, okay? If I'm looking for a negative arc tangent, I know I have to be in quadrant 4. So my two choices for ordered pairs that have a 3 anywhere in them, okay, are square root of 3 over 2, negative 1/2, and 1/2 negative square root of 3 over 2. So we need the one that would give me a tangent of negative square root of 3 over 3. Right here, 1 over square root of 3 would rationalize to this. So therefore, we were here at the same spot we were in the problem above it, which is at negative 5 or 6. So now we're back to find the cosine of negative pi over 6. So at that spot, the x-coordinate was square root of 3 over 2. Did some of you have that one done already or not? Good call. All right. All right, should we try to do these quickly together? Let me call on some people. Michaela, can you just find the cosine at pi over 3 for me? Yes, the x-coordinate at pi over 3 is 1/2. What angle has a sine of 1/2 that we have in our inverse sine 4? Cassidy, can you help me there? I need an angle though. Where is a sine value 1/2? So where's the y-coordinate 1/2? 30 or pi over 6. There we go. Number 20, inside out. What's the cosine at pi over 3, Taisir? Go to pi over 3, tell me the cosine or the x value. Oh, yours says 5 pi over 3. Okay, 5 pi over 3. Where is that? Yeah, 300. We already did this question. So at 300 degrees, what is the cosine? Tell me the x value. 1/2. Okay? Sarah, what angle has a cosine of 1/2 that actually has an inverse defined for it? Yes. All right, here we go. This is not as bad as it looks. This is an actual subtraction in here. What? Was this right? Oh, it's pi over 3. Yeah. I was thinking pi over 3 or pi over 6, and when she said pi over 3, it was right, and I didn't even think about the 2. Yep, it's got to be in quadrant 1. Positive x-coordinate pi over 3. Thank you guys for fixing me. All right, down here we start inside out. We're going to calculate this value, and then it's going to be subtracted this value. All right, where is the sine? What angle has a sine of 1? Jacob, can you tell me that? Where's the sine? The Jacob Martin. What? Sine is 1. Yes, at pi over 2. How about other Jacob Sanchez? Where is the cosine 1/2? I'm sorry. Can you just look quick? Where's the x value 1/2? On your unit circle. Okay. So now it says subtract, and then find the tangent of the resulting angle. I'd like to think you could all get a common denominator, but it's okay if you type 1/2 minus 1/3, math, enter. Throw the pi back on there. It's 3 pi over 6 minus 2 pi over 6, which is 1 pi over 6, which, or a 1/6, right, when you use your calculator. Okay, so now, Jared, can you go to pi over 6 and tell me what the tangent is? The y value over the x value. The coordinate at pi over 6 is square root of 3 over 2, 1/2. So it's y over x, which is square root of 3 over 3, which is what he said. Yes? We all agreeing? Okay. 22. This one's not as bad as it looks. It just has a tangent. Arctangent with a negative. That is a negative, not a minus. I don't know. Just looks kind of funny. Means we're in quadrant 4. Pi over 4? Okay. It should be a coordinate that looks like this, yes? So when we put the y, so when we put that y over the x, we get just negative square root of 3. And you said that was at negative pi over 3, yes? So what's the sign at that spot? Negative square root of 3 over 2. All right, yes? All right. We're moving back over to worksheet 21. All right. You have actually done questions like this before. This question, shh, guys, please. This question used to say, remember? It would say if the tangent is negative 3/4 and the angle theta is in quadrant 4, what is the cosine? And you had to draw it and figure it out, yes? It's asking the same thing. How do I know it's quadrant 4? Because inverse tangent is only defined in these two quadrants and it's negative. So I go here and I draw it. 3 and 4 are opposite and adjacent. Which one's negative? The 3 because I went down, right? Now it wants the cosine. What do we have to do quick? The square root of 16 plus 9, which is square root of 25, which is 5. So now it wants the cosine. The cosine at that spot is adjacent over hypotenuse, 4/5. All right. Some more of these. This one is just review. What's the sine at pi over 3, guys? Is square root of 3 over 2. Where is the cosine square root of 3 over 2? Okay, so the answer to that one was pi over 6. This is a draw question. Where's the tangent positive? Arctangent is only positive, can only be in quadrant 1 or 4, so it's 4, right? Positive, 1. Not negative, it says positive. That would be quadrant 1. Okay, tangent is opposite over adjacent. What's the sine at that spot? Sine, I need hypotenuse, yes? 5 squared plus 12 squared is 169. Square root is 13. So I need the sine, which is opposite over hypotenuse, or All right. The next thing we have is something you need for calculus, okay? For calculus, they ask you to do all these things in terms of x. It's not as hard as it sounds. We just have to be careful we don't oversimplify. This is what I mean by oversimplify. If this is A and this is 1, and I want to find something to write here, this is a missing leg, yes? And in geometry, we learned leg squared plus the other leg has an A on it equals hypotenuse squared. So to find leg squared, we would subtract leg squared equals 1 minus a squared. 1 squared minus a squared, but 1 squared is 1, right? And then we would square root both sides. All right? 1 squared is 1. So we have this. Remember what I just said? Do not oversimplify. Can you simplify 1 squared minus a squared? As in square root it? No. You could factor it, but you'd still have the square root of 1 minus a times 1 plus a. Let me back up for a minute and prove this to you, okay? If I had a 3, 4, 5 triangle, right? You would do 5 squared minus 3 squared equals x squared, yes? This would be the square root of 16, or I don't want to write it like that. I want to write the square root of 5 squared minus 3 squared. What you're telling me is you want those squareds and square roots to cancel so you get this. Is that the right answer? No. You have to do 25 minus 9 and get square root of 16, which makes this 4. There is no canceling. When you have a minus or a plus in the middle, you can't square root, okay? Period. You can't square root it. You got to leave it. So this question that we're going to go to right here, okay? We're going to draw this. We're going to assume it's positive. We're going to go into quadrant 1. The cosine is x. Cosine is adjacent over hypotenuse. We're going to put an x on the adjacent and a 1 on the hypotenuse. Now we need to figure out how to write an expression for here. Don't holler out because I know some of you can do this very quickly in your head. But if this is leg, I'd have x squared plus leg squared equals 1 squared. I'd subtract, and I'd have leg squared equals 1 squared, which is 1, minus x squared. Then I'd square root both sides. And we just learned that what's true. Can I simplify that? So the mess we write here is actually square root of 1 minus x squared. Now they want the sign of that disaster. So sine is opposite over hypotenuse, so we get square root of 1 minus x squared over 1, which is just this. Yes, we're going to do one where you have to rationalize in just a second, okay? All right, guys, this one looks really confusing to me because it says sine of x, and I'm thinking it should be a y, but it's an x. So I'm going to draw my little picture. Sine is opposite, so I'm actually going to put an x over there. Opposite over hypotenuse. Is it a different expression than the last one? This is still hypotenuse squared minus leg squared is still 1 minus x squared, right? Okay. Now I need the tangent. This is where you want to cry a little bit. Because tangent is... Oh, you have code... I didn't think you had that one. You have this one? Oh, you have both of these. All right. This one is better, yeah. This one isn't as bad. Okay, gotcha. Let's finish. Let's do the one. They're the same. This one is the same, both places. That's why I was so confused. Okay. So on the front side, we already did this one. And it says this. Now it says find the cotangent. Cotangent isn't that bad, actually, for this question. Because instead of opposite over adjacent, we get to do adjacent over opposite. Good news was we didn't have to rationalize anything. Now turn the worksheet over. And number 2, we have the same question, but it wants the tangent. Okay. So the answer to number 1 was just this, because it's the same question on both sides. Okay. We got to here. It wants the tangent, so it wants opposite over adjacent. Okay. Review for a second for a minute. When we had x over square root of 3, we did this and got x square root of 3 over 3, yes? So when we multiply by this, what are we going to get in the denominator? 1 minus x squared. And when we multiply it in the numerator, we have to multiply the same thing because it's a form of 1 here. So it's x square roots of 1 minus x squared. In calculus, it has to do with the fact that you can now find the differentiation of this, and you couldn't of this or some crazy business. I don't know. So if you decide to take calc, you'll need this. All right. I want you guys to do these on your own, except I think that G and H are a little confusing. Let's talk about G. What quadrant would we look for an inverse sign to be positive in? 1. And if we are doing an inverse sign and it's positive, it's in quadrant 1, sign is opposite over hypotenuse. People who know Pythagorean triples are going to want to put 13 there. But can it be 13? Because it's a leg. It's also not 7. We have to do hypotenuse squared minus leg squared. Square root of 119. Go you. And now we want the cosine, which is adjacent over hypotenuse. So it's square root of 119 over 12. What? Yes, it's a lovely answer. All right, let's try H. H says that we're looking at a positive x value, so an inverse sign with a positive value would be in quadrant 1. How am I going to label this triangle? Opposite over hypotenuse. So we're going to write an x and a 5, even though we want to call that y, because it's weird that x is going up and down, but we're going to put it there. Then it's hypotenuse squared minus leg squared. So we write square root of 25 minus x squared, which cannot be simplified. We want the cosine. What are we going to write? 25 minus x squared over 5. Each of the next 2 quizzes have one of those kind of problems where you have to write the expression, okay? I didn't put 10 of them on. I didn't put, it's not, there's one on each quiz. The only other ones that gave some students a little trouble, do this one real fast. Where's the tangent? -1, inverse tangent. Some people said -pi/2, but that would be just the y value is -1, right? We want y over x, so it's -pi/4. Everybody okay? What about E? Where's the cosine +1? And what is the sign at that same spot? This question is funky because it's not on your unit circle. Yeah, it would be square root of 3 over 3, but even that is not a cosine value on your unit circle. It is possible. 1 is smaller than square root of 3, so if you had adjacent over hypotenuse, how would you find the cosine of that angle? This would be root 2, but that's not what it's asking. It wants the cosine. So it'd be 1 over square root of 3, which, of course, because I mean, you're going to have to rationalize. But normally we only see square roots of 3 over 3 when we're talking about tangent, right? It's not one of our 30, 60, 90 triangles. All right. Can you finish the rest on your own? I didn't leave very many. So worksheet 22, there are some that tell you to answer in degrees. So if you have questions on those, let me know. These 8 questions that you need to add to page 288 that was already assigned, okay, are all of those kinds where it says find the cosine of the tangent of x. So you're going to get some square root of some crazy business. That was a really disgusting example I made up there.